So in this example, we have a child traveling down a water slide, leaving it with a velocity of 4.2 meters per second horizontally. That is going straight horizontal. Once the child leaves the slide, the child undergoes projectile motion, landing in the swimming pool, which is 3.2 meters below the slide. Few questions here. For how long is the child airborne? So in A, we are asking to find delta t. Now again, with any projectile, we need to separate the horizontal and the vertical components of the motion. So the 4.2 meters per second horizontally will not come into play for this. All that matters right now is how long it takes this child to fall 3.2 meters. With that in our head, the displacement of the child will be 3.2 meters down, because the child will fall down off the slide into the water. The acceleration the child experiences while falling will be due to gravity. And as we often do, we have to read a little bit into this question. We actually know the VI of the child. In the downward direction, this child's VI is 0. 4.2 meters per second is its horizontal speed, but its vertical speed is 0. Knowing this, looking at the variables, choosing an equation, we can use delta D equals VI delta T plus 1/2 A delta T squared. Substituting in what we know, delta D is 3.2, VI is 0, delta T we don't know, A is 9.8, and delta T again. Working this out, 0 times delta T is 0. We can multiply 1/2 times 9.8, give us 4.9 T squared. We didn't even need that 0, so we have 3.2 equals 4.9 T squared. Divide both sides by 4.9, and we get 0.65306 equal T squared. Taking the square root, we'll take this to 2 sig figs, and we get a time of 0.81 seconds for this child to fall. Moving on to question B, the child's horizontal displacement while in the air. This relies on the fact that the child's horizontal speed will be a constant 4.2 meters per second in the horizontal direction. Yes, the child will be accelerating and its vertical speed will be increasing, but horizontally will still be 4.2 meters per second. We just found the amount of time the child is in the air, 0.81 seconds. And we're trying to find the horizontal displacement. Because the speed is constant, we can use one of the simpler formulas. Substituting in V 4.2, delta D we don't know, and T 0.81. Cross multiplying again with 2 sig figs, we'll get 3.4 meters. Question C, the child's velocity upon entering the water. Again, we need to take into account both the horizontal and the vertical components of the velocity. What we know for sure, the child is traveling at 4.2 meters per second horizontally. And we don't know how fast the child is falling vertically. What we're being asked to find is the vertical, so again, we'll deal with the vertical side of this. VF, vertical, is what we're being asked to find. We've already dealt with the vertical side of it in question A, so we can use all of that information again. VI in the vertical direction is 0 as soon as the child leaves the slide. Acceleration is due to gravity. And the child's displacement downward is 3.2 meters. Dealing with this, looking for an equation, VF squared equal VI squared plus 2A delta D. VF is what we're solving for. VI is 0. A is 9.8. D 3.2. Working out the right side gives us 62.72. Taking the square root, going to 2 sig figs would give us 7.9 meters per second down. I'm just going to clear off the page to finish this. Because we have the horizontal velocity of 4.2 meters per second and now the vertical velocity of 7.9, now we can find the child's overall velocity. So we gain 4.2 meters per second horizontally. We now know 7.9 meters per second vertically. And we want the velocity in that direction. So Pythagorean theorem, with it being a right triangle, we'll call 4.2a and 7.9b. (4.2 squared is 17.64. 7.9 squared is 62.41. Adding those together is 80.05. Taking the square root, going to 2 sig figs, we get 8.9 meters per second. We also need the angle that the child's velocity is at. That is this angle here. With it being a right triangle again, SOHCAHTOA, we have the opposite of 7.9, the adjacent of 4.2. So tangent works here. Filling in. Working this out, again, make sure your calculator is in degree mode. 2 sig figs, 62 degrees. So then putting this all together, this child's velocity will be at 8.9 meters per second at an angle of 62 degrees below the horizontal.